Welcome back. Okay, so we have created our subject, user and service accounts in previous topic. Now, how do we give them the permission? We do this using two pair of API objects in Kubernetes, role and binding. Here the breakdown. Role is a defines of set of permission, a list of verbs and resources. A role is always namespace scope. For example, a role could say permission to list pods and services in dev namespace. A role binding then takes the role and binds it to the subject, a user or service account. This is what actually grants permission. It says give the pod reader role to the build bot service account within the dev namespace. But what if you need grant permission to cluster-wide resources like nodes, which don't belong to the namespace? Or what if you want to define a set of permissions once and apply it to many namespaces? For that, we have to cluster scoped equivalent. A cluster role is just like role, and its permissions are not tied to a single namespace. And a cluster role binding binds a cluster role to a subject across entire cluster. The key takeaway here is role define what you can do, and build and binding define who can do it. Let's put it into practice. Let's create a role for developer who only needs read-only access for a few core application resources in default namespace. We can create a role imperatively. We'll name it read-only and grant it list, get, and watch verb on pods, deployment, and services. So this is the way we created the command. So it's create role read only, the verb is list, get, watch, and resources are pod, deployment, and services. The alternative is to using the YAML declarative way instead of using imperative command line. So here I created the read only, and we can get it or describe it. Let's just describe it. The role to see what it does. So it gets pod, services, and the deployment list, get, watch for default namespace. Let's create a role binding for the user John Doe, again imperatively. So we assigning the role binding, and the name is read-only binding. It's the name of the binding name, and the role is read-only, and the user is John Doe. Remember that the role name can be anything. It doesn't matter. But the important thing is here is that using the existing role name, which we have here, and the user is John Doe. Okay, the binding is existing already in the cluster. I can remove it just to demonstrate how we can do it. Create role binding, and the name is read only role binding. Okay, now the binding is read only binding created, and also we can describe it to see what it does. So we have user John Doe and name is read only, which we associated this role to the user John Doe. Okay, so how we can test this? Kubernetes has a fantastic built-in command for this, kubectl auth can I. It lets you impersonate a user and check if they have permission to perform an action without needing to switch your entire kube config. Let's check. Can the user John Doe list pods? Okay. As you can see, it says yes, but this is only in default namespace. Okay, can it delete the pod? No, he can't. Delete verb was not in our role. The RBAC system correctly denies the request. What about listing the resources we didn't specify, like secrets? No. Again, access is denied. This is the principle of least privilege in action. If a permission is not explicitly granted, it is forbidden. Let's switch to another scenario. We want to list the pods in all entire cluster using John-Do user. We need to create a cluster role for listing pod and cluster binding for John-Do to be able to list pods in all entire cluster. Let's create a YAML file and name it John-Do cluster pod list YAML. And I'm using YAML definition to creating a role and role binding. The cluster role has list of pods name, and the resources pods get, list, and watch as a verbs. And the cluster role binding, the name is John Doe list pods binding, and it attached, the subject is John Doe, and the role is list pods. Let's save this, and let's apply this YAML definition to create the cluster role and cluster role binding for John Doe. Okay, as you can see, those are created. Now I'll get the list of pods in all namespaces using the John Doe credential get pods-a. As you can see, I can see all entire pods, even in kube system namespace, which are running. Okay, let's remove the role and role binding to see what happens if you repeat the same command without just deleting the, instead of having the role and role binding. Okay, I deleted the role and role binding, and now when I'm running the get pods-a, I can see that the user John Doe cannot list resources in API group, which means that we don't have access to list pods in all across namespaces. Let's go back to presentation. And the core Kubernetes RBAC, to recap, we have subjects, user for humans, service accounts for machines. We have roles defined in the roles for a single namespace or cluster role for the entire cluster, and we connect them together with binding. The role binding for namespace or cluster role binding for cluster. By combining this simple building block, you can create a fine-grained security policy that ensures every user and every application has exactly permission they need and no more. In our next topic, we will look at the key RBAC key objects in more detail and explore practical implementation. Thank you for watching.